open your own day. How will I know? Say my never see you again. How do you go? I love you. Oh, no. That's how it's not so. So, before you know, here's one more. I've been searching for where to say you should move on. But nothing you both know that you're better off after you're gone. You'll find somebody who looks at you where you used to look at me. Oh, nothing we both know. I'm not the man that I used to be. I'm so tired walking around, going out for one better now than our love was a garden, but it seemed weeds had grown. All the flowers will seem to all been sown. It won't hold through.
Hi, you're on the internet right now. Yes, you. Watching this video on a glowing rectangle connected to billions of other glowing rectangles through cables at the bottom of the ocean, bouncing data off satellites, routing through buildings full of computers that use more electricity than some countries. Also, you can learn about how this thing was invented. That's either beautiful or terrifying. Probably both. The internet is the largest machine humans have ever built. It connects over 5 billion people. It processes more data in a single day than all of human history produced before 1900. It knows what you search for at 2 a.m. It remembers that thing you bought once and will never stop showing you ads for it. So how did we get here? How did humanity go from what's a computer to my fridge just sent me a notification? Buckle up. This is going to get weird. The internet exists because people were afraid of getting nuked. No, seriously. It's 1957. The Soviet Union just launched Sputnik into space. It's a metal ball that beeps. That's literally all it does. But America loses its collective mind. If the Soviets can put a beeping ball in space, what's next? Nukes from orbit? Space lasers? Mind control satellites? The US government panics and creates ARPA, the Advanced Research Projects Agency. Their job? Make sure America never gets out-teched again. One problem they tackled was communication. See, in the 1960s, if you wanted two computers to talk, you needed a direct wire between them, like a phone call. One line, two endpoints. This is called circuit switching. Works great until someone drops a bomb on the phone exchange. then your whole network dies. Game over. Everyone goes home. Except home is also nuked. So some very smart, very paranoid people asked, what if we built a network with no center? A network where if you blow up one part, the rest just keeps going, like a cockroach, but for information. That idea would accidentally create the thing you're wasting your life on right now. In 1966, ARCA hired a guy named Bob Taylor to figure this out. He had 3 computer terminals in his office connected to 3 different computers at 3 different universities. 3 separate logins, 3 separate systems, 3 separate headaches. What if, he thought, they could all just talk to each other? He got $1 million, he hired some brilliant weirdos, and in 1969, they built ARPANET, the great-great-grandfather of the internet. It connected 4 computers. 4. That's it. UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah. The first message ever sent was supposed to be login. The system crashed after 2 letters. The first message on the internet was LO. The internet literally started with a crash. Honestly, perfect foreshadowing. But here's the thing that actually made it work: packet switching. And no, that's not a magic trick. Old networks sent information like a train, one long stream, start to finish. Chugging along a single track, if the track is blocked, nothing moves. Everyone waits. Packet switching is different. You chop your message into tiny pieces called packets. Each packet gets a label saying where it came from and where it's going. Then you yeet them all into the network like confetti at a parade. They might take different routes. One packet goes through Chicago, another through Dallas. A third one takes a scenic route through who knows where. Doesn't matter. The computer on the other end collects them all and puts them back together like a puzzle. Why is this genius? 2 reasons. 1, resilience. Blow up a computer, packets route around it. The network heals itself like Wolverine. 2, efficiency. Multiple conversations share the same wires at the same time. You're not hogging a whole cable for one message, like some kind of data hog. A guy named Paul Barron at Rand Corporation figured this out. So did Donald Davies in Britain independently, around the same time. Sometimes ideas are just ready to be born. Sometimes 2 nerds on opposite sides of the ocean have the same brilliant thought. It happens. Okay, cool. Computers are talking. ARPANET grows. By 1971, it has 15 nodes. By 1973, 40 nodes. By 1977, over 100. Universities and research institutions are connecting like it's some kind of nerd party. But here's another problem. They're all speaking different languages. An IBM computer trying to talk to a DEC computer is like a cat trying to have a conversation with a toaster. Lots of noise, 0 communication, maybe some sparks. Every network had its own rules, its own protocols. ARPANET spoke ARPANET. Other networks spoke their own thing. If you wanted them to talk to each other, someone had to translate. This was annoying. Enter Vint Cerf and Bob Kahn. In 1974, these 2 heroes invented TCP/IP. That stands for Transmission Control Protocol and Internet Protocol. Don't worry, there won't be a test, probably. Here's what it does. IP, the Internet Protocol, handles addressing. Every device on the internet gets a unique number called an IP address. It's like a phone number, but for computers. When you send data, IP figures out where it needs to go and routes it there. It's the postal service of the internet, but faster and with fewer packages getting lost. TCP, the Transmission Control Protocol, handles reliability. Here's the thing about packets. They can get lost. Wires get cut, servers crash. Things happen. TCP keeps track of everything and says, hey, packet number 47 didn't arrive. Send it again. It's the responsible friend who makes sure everyone gets home safe. Together, TCP/IP is a universal translator for computers. Any computer running TCP/IP can talk to any other computer running TCP/IP. It doesn't matter who made the hardware. It doesn't matter what operating system it runs. It doesn't matter if it's a supercomputer or a toaster with Wi-Fi. If it speaks TCP/IP, it's on the network. Here's the wild part. This is still how the internet works, right now, today. Every time you load a web page, watch a video, send a message, you're using technology invented by 2 guys in the 1970s. That's either incredible engineering or proof that nobody wants to rewrite the foundation when it actually works. In 1983, ARPANET officially switched to TCP/IP. January 1st, they called it Flag Day. Every computer on the network had to switch at the same time. It was like a synchronized swimming routine, but for nerds. It worked, and the modern internet was technically born. But wait, we've been talking about wires and protocols. What were people actually doing with this thing? Mostly boring stuff at first. Sharing files, running calculations on remote computers. Very exciting if you're a physicist. Very boring if you're anyone else. Then, in 1971, a guy named Ray Tomlinson invented email. And suddenly, people had a reason to care. He wrote a program that let you send messages between computers on ARPANET. Simple enough. But he needed a symbol to separate the username from the computer name. He looked at his keyboard. He saw @. the @ symbol. Nobody was using it for anything. Sure, why not? He probably said, not realizing he was creating one of the most recognized symbols on Earth. And that's why @ is everywhere now, because a programmer in 1971 thought, this works. History is weird. The first email was probably just a test, something like "Quirt you up." Tomlinson doesn't even remember. He sent a bunch of test messages to himself. Very historic, very anticlimactic. But email caught on fast, like really fast. By 1973, email was 75% of all ARPANET traffic. Turns out, people really like talking to each other, even through machines. Who knew? The internet's first killer app wasn't complicated. It was just communication. More networks popped up through the 70s and 80s. Usenet launched in 1979. It was like Reddit before Reddit, people posting messages to news groups about science, computers, and, predictably, arguments. The internet's proud tradition of strangers yelling at each other started early. By the mid-1980s, the internet was growing but fragmented. Different networks existed, but connecting them was complicated, like different countries with no roads between them. The US government stepped in. In 1985, the National Science Foundation created NSFNet, a high-speed backbone network connecting supercomputer centers. They used TCP/IP, more universities connected. Then more. The network went from thousands of computers to hundreds of thousands. But the NSF had rules. NSFNet was for research and education only, no commercial traffic, no business. No capitalism, strictly nerds only. Obviously, that couldn't last. Businesses saw the internet and wanted in. By 1991, the rules relaxed. Commercial internet service providers emerged. Companies like PSINet and UANet started selling internet access to regular people. By 1995, the NSF shut down NSFNet entirely and handed everything over to private companies. The internet went from government project to private infrastructure. This changed everything. Money flooded in, growth went exponential. The internet was officially open for business. But we're getting ahead of ourselves. There's one more invention we need to talk about. The thing that made the internet usable for normal humans who didn't want to learn command line interfaces. The World Wide Web. Quick clarification, because people mess this up constantly. The internet and the web are not the same thing. The internet is the infrastructure, cables, routers, protocols. The plumbing, the web is an application that runs on top of it. The internet is the road. The web is the car. You don't drive on the car, you drive the car on the road. Got it? Good. Moving on. In 1989, a British scientist at CERN named Tim Berners-Lee had a problem. Researchers generated tons of documents, but everything was scattered across different computers in different formats. Finding anything was like looking for a specific grain of sand on a beach. At night, while blindfolded, during a sandstorm. His solution was elegant. Hyperlinks. You're reading something, you see something interesting, you click it, boom, you're somewhere else. Documents linked to other documents, information connected to other information. Simple, obvious in hindsight, revolutionary at the time. He created three things: HTML, hypertext markup language for creating web pages, URLs, uniform resource locators for finding them, and HTTP, hypertext transfer protocol for transferring them. Put them together, and suddenly you can click a link and see a document from a computer on the other side of the planet in seconds. The first website went live in 1991. It explained what the World Wide Web was. Very meta. Very nerdy. Still exists, actually. You can visit it. It's beautifully ugly. But here's the problem. Using the early web still required knowing stuff. Commands, protocols, technical nonsense. Regular people who just wanted to read things didn't have time for that. Enter the browser. In 1993, a team at the University of Illinois created Mosaic. It was the first browser that didn't make you want to throw your computer out the window. It showed images, inline with text. Revolutionary. It had buttons you could click. Amazing. It worked on Windows, Mac, and Unix. Incredible. This sounds basic now, but in 1993 it was like magic. Downloads went crazy. The web went from nerd toy to actual thing regular humans used. One of Mosaic's creators, Mark Andreessen, went on to co-found Netscape in 1994. Netscape Navigator became the browser. Fast, pretty, made the web feel like the future. Everyone used it. Everyone loved it. Then Microsoft noticed. And when Microsoft notices something, things get messy. Microsoft created Internet Explorer and did something clever and slightly evil. They bundled it with Windows for free. Every computer with Windows had IE already installed. You didn't have to download anything. It was just there. Netscape charged money. IE was free. Netscape required effort. IE required nothing. You can guess what happened. By 2000, Internet Explorer had 95% market share. Netscape was dead. Microsoft won by literally giving away the weapon. This was called the Browser Wars, and Microsoft won by making the war pointless. Microsoft got sued for anti-competitive behavior, said bundling IE with Windows was unfair. The case dragged on for years. Lawyers got extremely rich. Microsoft eventually settled, the internet kept growing regardless. Now let's talk about the part where everyone collectively lost their minds, the dot-com boom, and then the dot-com bust, and then the survivors becoming more powerful than most governments. Here's what happened. Investors looked at the internet in the mid-1990s and saw the future. They weren't wrong, the internet was the future, but they also completely disconnected from reality and started throwing money at anything with a website. Any company with .com in the name could raise millions. Business model? Optional. Revenue? Overrated. Profits? What even are those? Just grow. Growth is everything. Figure out the money part later. Pets.com sold pet food online. They raised $300 million. They spent $11.8 million on a Super Bowl ad featuring a sock puppet. They went bankrupt in less than a year. The sock puppet became a symbol of the entire disaster. It now lives in memes. Webvan promised same-day grocery delivery. They built massive automated warehouses before they actually had customers to use them. Burned over $1 billion. Dead. Boo.com was a fashion retailer with a fancy 3D interface that required broadband internet speeds most people didn't have yet. They burned $135 million in 18 months trying to sell clothes on an internet that couldn't load their website. Also dead. The theory was simple. The internet is the future, so internet companies must be valuable. But this is the future, and this is valuable right now, are different statements. A lot of people forgot that distinction. In March 2000, the bubble popped. The Nasdaq peaked at 5,048 points and then collapsed like a house of cards in an earthquake. By October 2002, it had lost 78% of its value. Trillions of dollars evaporated. Companies worth billions became worth zero literally overnight. People lost everything. The hype was stupid, but the technology was real, and the companies that survived, they became the giants that now run our lives. Amazon started selling books, just books, then everything else, then they built AWS and became the infrastructure that half the internet runs on. Now they're worth over $1 trillion, and Jeff Bezos went to space for fun. eBay connected buyers and sellers and took a percentage of every transaction. Simple model, massive scale. And then there's Google. Let's talk about Google, because they basically own the internet now. Founded in 1998 by two Stanford PhD students named Larry Page and Sergey Brin, they were trying to organize information. That's it. Their insight was elegant. Existing search engines were garbage. You'd search for something and get pages of irrelevant spam. Their idea? Rank pages by how many other pages link to them. If lots of pages link to you, you're probably important too. Simple logic. They called the algorithm PageRank. Get it? PageRank? Larry Page? Yeah, they were that kind of nerd. The naming scheme was intentional. It worked. Google actually showed you what you were looking for. It felt like magic compared to everything else. People switched fast, but here's the genius part. Monetization. Google showed small text ads next to search results. You're searching for running shoes? Here are some running shoe ads. You're searching for lawyers? Here are some lawyer ads. Relevant advertising at the exact moment someone is looking for something. This is called search advertising. It's why Google makes over $200 billion a year. It's why Google it became a verb. It's probably why you're watching this video, actually. By the mid-2000s, the internet had recovered from the crash. But something fundamental was shifting. The web was becoming read-write instead of read-only. Users weren't just consuming content anymore. They were making it. People called this Web 2.0. Nobody agreed exactly what that meant, but the vibe was clear. You make the content now, the platform just hosts it. Wikipedia launched in 2001, an encyclopedia that anyone could edit. Anyone. Random people. Experts were horrified. This will be chaos, they said. Lies everywhere. Vandalism, no quality control. Turns out, collective effort plus volunteer editors plus version history plus community notes equals actually pretty accurate information. Not perfect, but good enough. Wikipedia is now one of the most visited websites on Earth. It runs entirely on donations. It still works. Nobody really understands how, but it does. YouTube launched in February 2005. The idea? Let anyone upload video to the internet. The first video was one of the founders at the San Diego Zoo talking about elephants, 18 seconds long. Not exactly cinema. But the platform exploded. Suddenly, anyone with a camera could broadcast to the entire world. No TV network needed, no permission required. Just upload and go. Google bought YouTube in October 2006 for $1.65 billion. Everyone said they overpaid. YouTube now generates over $30 billion in annual ad revenue. Everyone was wrong. Then came social media, which is either the greatest human connection tool ever invented or a psychological weapon slowly destroying civilization. Depends who you ask. Probably both. Facebook launched in 2004 from a Harvard dorm room. Mark Zuckerberg and some roommates built it. The original idea was rating how attractive your classmates were. That was creepy, so they pivoted to a social network called the Facebook. Then they dropped the because that's what cool companies do. It spread to other Ivy League schools, then all colleges, then everyone with an email address, then your parents' weird friends from high school. By 2012, Facebook had 1 billion users, a billion people on one platform. That's more than most religions. Twitter launched in 2006. The concept, short messages, 140 characters maximum, that's it, seemed pointless, became incredibly influential. Presidents used it to announce policy. Revolutions were organized on it. Also, lots of people yelling into the void at 3 a.m. Mixed results overall. Instagram, 2010, photos with filters that made everyone look like an artistic genius. Facebook bought them for $1 billion in 2012. People said overpaid. People were wrong. Snapchat, 2011, messages that disappear. Your parents didn't understand it. That was the entire point. TikTok, 2016, short videos with music, an algorithm that understands you better than you understand yourself. Hours vanish. Your attention span shrinks to nothing. You keep scrolling anyway because the algorithm knows exactly what you want to see next. Here's the thing about all these platforms. You're not the customer, you're the product. These services are free because they're selling your attention to advertisers. Your eyeballs, your clicks, your data, your time, your habits, your preferences, your fears, your desires. That's what they sell. You're just the source material. Speaking of fundamental changes, let's talk about the thing in your pocket. In 2007, Steve Jobs walked onto a stage and introduced the iPhone. He said it was three things: a widescreen iPod with touch controls, a revolutionary mobile phone, and a breakthrough internet communicator. 3 devices in one. Critics said it was too expensive. $499 with a contract. For a phone, they were right about the price. Critics said you couldn't change the battery. Also correct. Critics said it would flop. Very, very wrong. The iPhone didn't just change phones, it changed the internet itself. Before smartphones, you went to the internet. You sat down at a computer, you logged on. It was an activity with a beginning and an end. After smartphones, the internet goes with you. It's always there. In your pocket, on the bus, in bed, in the bathroom. Especially in the bathroom. Don't pretend you don't do this. Everyone does this. Google released Android in 2008. Smartphones became affordable. By 2016, more people accessed the internet via mobile than via desktop computers. The line between online and offline started to blur. The internet stopped being a place you visit and became the air you breathe. This enabled entirely new things. Uber doesn't work without a phone that knows exactly where you are. Instagram is pointless without a camera in your pocket. Dating apps don't work without actually loneliness predates smartphones. But the apps need GPS. You get the point. Apps became the new websites, walled gardens instead of the open web. You download the app, you stay in the app. The app tracks everything you do in the app. Very convenient, very contained, very profitable. Meanwhile, behind the scenes, another quiet revolution. Cloud computing. The old way, you want to run a website, you buy physical servers, actual computers. You put them in a room, you plug them in, you keep them cool. If you need more capacity, you buy more servers and pray they arrive before your site crashes. Amazon Web Services launched in 2006. Their pitch was elegant. What if you could rent computing power instead of buying it? Need 10 servers? Here. Need 10,000 servers for 1 hour? Here. Scale up instantly? Scale down when you're done. Pay only for what you use. This was transformative. A startup could build something massive without any hardware. No servers, no data centers, no upfront cost. Just code and a credit card. AWS, Google Cloud, and Microsoft Azure now power most of the internet. That app you love? Probably running on Amazon's computers in a warehouse you'll never see. Streaming changed how we consume media. Netflix started as a DVD mail service. Remember DVDs? Then in 2007, they added streaming. Watch anything, anytime, no waiting. This killed Blockbuster, changed television, changed movies, made appointment TV obsolete. Everything on demand forever. Spotify did the same for music, YouTube for video. The entire entertainment industry restructured around streaming. So where are we now? The internet is controlled by a handful of giant companies. Google dominates search, Meta dominates social networking, Amazon dominates e-commerce and cloud infrastructure. Apple and Google control the mobile operating systems. Microsoft controls productivity software. That's basically it. 5-ish companies running most of human digital experience. These companies have more users than most countries have citizens. They have more data about human behavior than any government has ever collected. They have more power over information flow than any organization in history. The modern internet runs on algorithms, software that decides what you see, when you see it, and in what order. Your social media feed isn't chronological. It's curated by machine learning models trained to maximize engagement. What maximizes engagement? Strong emotions. Outrage, fear, anger, shock. Calm, nuanced, thoughtful content doesn't get clicks. Rage does. So the algorithm's optimized for rage, not intentionally, not maliciously, just mathematically. They're not trying to make you angry. They're trying to keep you watching. Anger just happens to work really well. This has created problems. Filter bubbles where you only see what you already believe. Echo chambers where your views get amplified until they're extreme. Misinformation spreading faster than fact-checking can correct it. The internet that was supposed to connect humanity has, in some ways, driven us apart into warring tribes. But it's also genuinely amazing. Remote work, online education, video calls with family across the planet, access to all human knowledge in your pocket. Anyone can publish anything and reach anyone. That's incredible. That's never happened before in human history. What's next? AI is already reshaping everything. Chatbots that write, image generators that dream, recommendation systems getting smarter and creepier. The line between human-made and machine-made content is blurring rapidly. Virtual reality might create entirely new online spaces. The metaverse got massively overhyped, and Facebook embarrassed itself changing its whole company name, but the underlying idea of shared virtual spaces isn't dead. The internet might fragment. China has the Great Firewall. Russia is building its own isolated system. One global internet could become many smaller separate internets. That would be a fundamental change. Or maybe something completely unexpected happens, something we can't even imagine yet. That's kind of been the pattern so far. So what have we learned? The internet started as a military project to survive nuclear war. It became an academic network for sharing research. Then a commercial platform for selling things. Then a social network for connecting people. Then the nervous system of human civilization. It runs on packet switching, TCP/IP, DNS, and the World Wide Web. It lives in cables at the bottom of the ocean, satellites in orbit, data centers in the desert, and the phone in your pocket. It gave us email, websites, search engines, social media, streaming, memes, online shopping, remote work, video calls, and the ability to argue with strangers at 3 a.m. about things that don't matter. It also gave us surveillance capitalism, attention addiction, information warfare, filter bubbles, and the constant nagging feeling that everything is happening everywhere all at once, and you're always somehow behind. The internet is a tool, the most powerful communication tool humans have ever built. What we do with it is up to us. Anyway, thanks for watching. You can go back to doom scrolling now, which, let's be honest, is probably what you were doing before.
Any tests or documentation, and no one was at stand-up. Is everyone out of the office today?
Started up the startup, I'm the CEO. Name an algorithm, I'll give you the big O. Used to work at Netflix in case you forgot. Now I stream on Twitch, giving you brain rot. Always move forward, no rollback, split keyboard. It's Dvorak, sitting on a ball is for the low back. Never finished projects. Yeah, problems.
Got 1, 2, 3, don't solve them. Won't fix, not problems.
Cashed out, crashed out, and forgot them.
Yeah, problems. Yeah, problems. Yeah, problems. Yeah, 1, 2, 3, don't solve them. Sick of indie hackers faking MRR threads. You telling me that your project ain't dead? $12 monthly, you're a mogul in your head. 37 prompts just to turn a button red. What? Your product, pathetic. Your customer's apathetic. Mom's your only user and she doesn't even get it. My growth, frenetic. My retention is hermetic. All your tests are passing, but your traffic stays synthetic. Bro, I picked your DB and the only user is you.
England is my city, Sir David of design. Auto laid you out whilst on my Figma grind. Your GPT slop is 10 years behind. Parliament decided your product's in decline. That's as British as I go.
Don't worry, bruv. I got this. Made a whole career giving code away for free. Now I'm on a yacht with my friends around me. Started with a call, let's sell some coffee. SSH storefront, the license, MIT. Call me Obi-Wan, gave SSH a new hope. Where we're going, see us with a telescope. Shipping coffee like a machine. Moving so fast like Lightning McQueen. Ka-chow.
unit tests, pull requests, redundancy, security, JavaScript, TypeScript, QA skipped, bug shipped, sobriety, sanity, loneliness.
Oh, seriously? Loneliness?
SSL, TLS, DNS, VPN, IAM, IDE, IDP, and SCAD.
Yeah, problems.
Got 1, 2, 3, don't solve them. Won't fix, not problems.
Cashed out, crashed out, and forgot him.
Problems. Problems.
Great. Well, thank you very much for the kind introduction. It's very exciting to be at the first actual full scale Switzerland thing. So I hope that they can this is a success, and I hope they keep growing to the point where the idea that this is full scale will sound like a complete joke from 5 years from now. So. Wishing this best of luck. But in order for that kind of scaling to happen, one of the important problems that I think all of these pop-ups need to solve is the economics, right? And the reason why I think it's important to think about this now is that I think there's been this growing consensus that in order to actually do things that are socially interesting and not just have parties, we have to move beyond short-term things where the overhead of setting things up is just very high, and you're basically gaining novelty value, but you're not as able to go deep on things and actually create things that last for very long periods of time. And there's a big difference between the economics between a short-term thing and something that lasts a very long period of time. Because with a short-term thing, it's inherently very self-contained. So you have participants, they give you some money, and possibly they pay some money for accommodations themselves. You do the thing, and then the thing lasts for 1 or 2 months. The governance risk is low because if something screws up, then that particular organizer just has the reputation wrecked, and then the thing only lasts for 2 months, and the risk is just very bounded. Everyone moves on to something else, and all of these things do not apply to a permanent location, right? So for a permanent location, first of all, realistically, you have to buy land. Buying land is expensive. You'll have to probably buy structures. Structures are expensive. These things are not capital efficient. And these things require huge amounts of upfront capital, and they require upfront capital that a lot of people cannot afford. And if we want to talk about getting upfront capital, this is the exact point at which some of these questions between economics and values, especially in the Ethereum ecosystem, have turned into really big points of friction, right? So projects, to start off, they launch tokens, and then it turns out 3 or 4 years later, the token is a permanent burden on the projects that basically just permanently hampers their choices of being their ability to be perceived as neutral, their alignment with the Ethereum ecosystem, and all kinds of things, right? And so, when you build something permanent, you have to raise capital. There's no way around it, and you cannot rely on donation funding, because donation funding is just inherently limited. Donors are not going to go and buy up huge amounts of land at a large scale. And we need something that actually solve these problems in a way that aligns with the goals of the project, right? So I think our goal is, 1 is raising capital. 2 is, I think, we need more kind of crypto native, honest wealth building opportunities. So we need more things that are. And to me, the realistic alternative to pub fun is just good old fashioned 1,000-year Lindy traditional wealth building, which includes the equivalent of investing in companies and also investing in things like real estate. And so these are things that are not going to double your money in a week, but they are things that if everything goes well, double your money in a decade. But we actually have to build these things, and we have to make them in a form factor that's actually native to some of the other kind of goals that we have. And also, we want to create economic alignment between residents and each other, and between the location, right? Basically, if you have too much of a divergence between who owns it and who lives in it, then at best, the people living in it who are in the best position to improve it won't feel an incentive to improve it. At worst, people will start feeling that it's some kind of colonialism, and then people who have the tokens, they just start like thinking about it as a money-making thing, and then it ends up being more divorced from any other goals of the project. And so we want to try to create more economic alignment, right? So one other way of thinking about the goals is you want to create a structure that has the upsides of home ownership without the downsides. Like, I think this is basically the core one-sentence goal of figuring out economics of any of these pop-ups. So let's start with city tokens, right? So, if you give a crypto person the job of creating economic structure, they're just going to like slap an ERC20, fork the compound DAO, and like throw people some tokens and call it a day, right? So let's like start with that as a default, and let's like motivate better designs by critiquing the default, right? So two problems. One problem is homeowners want a stable guarantee that they can live in a place, right? And basically, if you're not a homeowner, then one of the challenges that you have is like you are, in a very real sense, negatively aligned with the place that you live in, because if the place that you live in suddenly becomes super successful, it becomes super popular, then we invented the word gentrification to describe this, and we consider it bad, right? But like, it's not bad. Like, it's the bad thing is the negative alignments, right? And so you want the basic thing that you want is if a place becomes more popular, like you do not like long-time residents should not be priced out. And also, if a community becomes a success, then like the long-term residents that made it a success should be the ones that succeed the most by default. So this is one thing that city tokens don't like naturally do, because there isn't too much like pressure for people to like for alignments between city token holdings and like actual like participation and residency in a place. And then this is also the other problem, right? Which is this like natural disparity between the types of people who would get city tokens and the types of people who would be owners, right? Like, if you look at an ownership chart of any realistic token, especially one that's a smaller scale, like how many people do you think you need to get to like 50% ownership of the whole thing? Who here thinks it's like over 10? Okay, who here thinks it's over 3? Okay, under 3? Yeah, see, like, do you want to live in a city where 3 people own 50% of it, right? Who here would? Okay. So now we see some. What if 3 people own 50% of it, but they're like random whales that are based off in Saudi Arabia? Well, the ideal thing that we want is like we want something where the people who are in a position to contribute actually feel the incentive to contribute, right? And I think you also want, like, if you end up having ownership be connected to governance, then like you want distributed ownership if you want the stability benefits of distributed governance. So let's talk about improving on city tokens, right? So here's like one strawman design, right? Suppose that you have a city. In that city, you have.
This is a Bitcoin. It is pretty much, it's a peer-to-peer virtual currency. Let me see if I can pull that up right here. So, what is Bitcoin? Bitcoin says just that it is a peer-to-peer. Bitcoin is a peer-to-peer currency. Peer-to-peer means that no central authority issues new money or tracks transactions. These tasks are managed collectively by the network. So, yep, that's what their website says. But pretty much, you can trade your real money, like real money, for Bitcoins, which are files stored on your computer. Or flash drive device, any sort of device, and they can be used as money on certain websites, etc. In fact, I have a list of the websites that accept it right here, and there's a couple of different ones, such as, there's one that actually, some of them were created for Bitcoin, such as Bitcoin Gadgets, which is a site that has electronic gadgets with international shipping at bitcoingadgets.com. See, there's a whole bunch of these. Well, let's see, for gift cards, you can buy gift cards with Bitcoin bitcoins at bitcoincodes.com, which sells Xbox Live, PSN, and Game Time codes. But now may not be the best time to buy PlayStation Network gift cards. Just letting you know. If you're watching this from the future, then a couple days ago, the PlayStation Network was hacked, and a bunch of credit card numbers were reportedly stolen. But anyway, also there's stuff like professional services like Bitcoin consultancy. There's a whole bunch of different things. You can find that list at if you go to bitcoin.org and then click on sites that accept Bitcoin, it'll give you the whole list. Also, I have the trading site up, or the share site, Bitcoin charts, and it looks like right now 1 Bitcoin is equal to about $8 US, which is and also about 7.5 GBPs, 11.5 Brazilian dollar, or Brazilian. What's the Brazilian currency? Sorry. The Brazilian reals. Okay, sorry. Yeah, I'm not really good with the South America currencies. Anyway, so that's all pretty neat. But they're referred to, if you see BTC anywhere, that will generally be referring to Bitcoins. For example, 100 BTC. But a Bitcoin, like I said earlier, it's a file, or it's a binary number associated with a Bitcoin address, which is stored in a file on a flash drive, device, computer, whatever. So, and it says, I'm reading this site and I'm paraphrasing, but how are new Bitcoins generated? They're generated by a network node each time that it finds the solution to a certain mathematical problem, which is difficult to perform and can demonstrate a proof of work. And the reward for solving a certain problem is being automatically adjusted so that in the first 4 years, 10,500,000 Bitcoins will be created. And then the amount is halved each 4 years, so the next 4 years there will be 5,250,000, etc. And then, let's see, currently there is, let me see, sorry, this information, okay, wow, there's 6,220,800 Bitcoins currently in existence, and it says that around year 2140, the total number of coins will remain static at 20,999,999.9769 Bitcoins. That's a lot of Bitcoins. So that's a lot about it. And then also, lots of people are wondering how can they get their own Bitcoins to make purchases on these sites, or just to invest in them in case Bitcoins become like an international currency. If you go to let's see,